Okay, so today we're going to be working with an epsilon delta proof, and we're going to be looking at the limit as x approaches 2 of x squared equals 4. So the two general equations that we must have memorized is that the absolute value of f of x minus L is less than epsilon, and x minus c is less than delta. So when we're going about solving these types of problems, it's very important to recognize that we know what f of x is, we know what the limit is, and we know what c is. So our very first step is going to be filling in what we already know. So f of x in this case is x squared, and the limit is 4, and this will be less than epsilon. And on this side, so we're going to have two equations. This side, x minus 2 is less than delta. All right, so once we have this, our objective of this entire proof is to relate epsilon to delta. So keeping that in mind, the only way that we can relate two of these variables is with something that they have in common. And the something that they have in common is the variable x. So our objective within a delta epsilon proof is to essentially make this side look like this side such that we can relate epsilon and delta. So I'll show you what I mean by that. Let's look at the left-hand side. We have x squared minus 4 is less than epsilon. We're going to factor that into x plus 2 times x minus 2 is less than epsilon. So now we have an x minus 2 term here and an x minus 2 term here. So to isolate x minus 2, which is what we're going to relate our epsilon and delta with, we're going to simply divide the left side by x plus 2 and the right side by x plus 2. All right, so in doing so, we have essentially eliminated this term, and we'll be left with an x minus 2 absolute value is less than epsilon over x plus 3, or sorry, x plus 2. And let's not forget, on this side, we have x minus 2 is less than delta. So the important question comes up of, so what? We have two inequalities, but what can we do with these two inequalities as of now? Well, we have that absolute value of x minus 2 is less than epsilon over x plus 2, and absolute value of x minus 2 is less than delta. So as a result, what we can do is we can actually relate the two in this fashion. So we'll have epsilon over x plus 2 equals delta. So, okay, great. Now we have a relationship, except we still have this x variable. So the question is, how can we eliminate the x variable? Now, when this question arises, we have to consider the fact that we can only adjust where we view the function on the x-axis. We cannot control what the function itself will look like. So in other words, this means that we can actually bound our delta, and we can put restriction on our delta as we please, but we may not do so for epsilon. So let's bound our delta expression. We're going to say let delta be less than 1. And if you recall from our previous page, we have that x minus 2 is less than delta. So applying that, we're going to have x minus 2 is less than 1. Now let's solve this inequality. To get rid of the absolute value, we have negative 1 is less than x minus 2, which is less than 1. And our inequality will yield us a 1 is less than x, which is less than 3. So we have a range of x values, or a domain of x values, that we can plug into this equation, epsilon over x plus 2 equals delta, to get our final answer. So at this point, we need to ask ourselves, okay, what do we want our delta to be? If you recall the delta epsilon proof, we want our delta to be as small as possible. So in this case, we ask ourselves, how can we make our delta as small as possible? Well, if we were to plug in x equals 1, we would have epsilon over 1 plus 2, or epsilon over 3 equals delta. If we were to plug in x equals 3, we'll have epsilon over 3 plus 2 equals delta, which would yield us epsilon over 5 equals delta, which is the smallest value that we can get. So in this case, our value that we want to use is x equals 3, and this yields us epsilon over 5 equals delta. Now, this is not our final answer, but this is a portion of our final answer. We need to remember that we set a restriction on our delta, and our original delta restriction was that delta is less than 1. So therefore, our final answer is that our delta min, so our smallest delta, occurs when it is restricted by 1, and our answer is epsilon over 5. Now, I know that epsilon delta proofs are very confusing. It's confusing for even tutors. If you have any other questions, please feel free to drop into the AATC Drop-In Tutoring and ask one of the tutors, and I'm sure we'll be able to help you out some more. I hope this video helped you all, and thank you for your time.